All right, hello and welcome, and this is Dr. K, and today I'm going to talk to you about material condition modifiers. All right, so today I want to talk to you a little bit about material condition modifiers, and there's two that I have in mind, and this will probably be a short video, but we'll see how it goes. The two material condition modifiers that we're going to work with are what we call maximum material condition and least material condition. And those have symbols, maximum material condition and least material condition. Those material condition modifiers are just a useful tool that we're going to be able to employ so that we can apply our geometric tolerances at certain material conditions. And in this particular case, we're going to deal with maximum material condition, least material condition. And I guess I'm cheating a little bit. There is a third, and it's regardless of feature size. If you have no symbols, then we use regardless of feature size as our material condition modifier. So now that we understand what a feature of size is, we can talk about what the material condition modifiers do. And essentially, what they are is what the name is. And so the example I might give is the simplest example possible is that if we have a hole in some part and it has a dimension, right? We're going to have some dimension. Let's say it's 1 inch and it is going to have a tolerance, let's just say of 0.1 inches. So this hole is allowed to vary by plus or minus 0.1 inches. It is a hole, and so if we wanted to know what this feature is at maximum material condition, we do just that. When does this hole have the maximum material? Well, when's a hole have the maximum material? Well, you probably guessed it. It is when it's its smallest size. So in this particular case, we'll be dealing with a 0.9 inch hole is the maximum material condition for this hole. If we're going to deal with least material condition, you guessed it, it sounds exactly like the material modifier. Where is the least amount of material for this particular part? Right? You've got it, 1.1 inches. So when this hole is produced at 1.1 inches, that's at the least material condition. Now the opposite holds true when we deal with a cylinder. So if we had a cylinder or a peg, and this peg happened to have the exact same, let me make sure we're in frame, had the exact same dimension, the exact same tolerance, that's a 1 by the way. Well again, so since we're dealing with a peg, maximum material is, I hope you guessed this right, the largest peg, least material condition, smallest peg. We've got it, right? 1.1 and 0.9. So those are what the maximum material condition and the least material condition are, in this case for a hole, in this case for a peg. Now this can be applied to any feature of size that we're going to work with. So whether that is a regular or irregular feature of size, we can apply these material condition modifiers so that our geometric tolerances are applied at these conditions. What you have to understand, and this is the biggest, most common mistake that I see when employing material condition modifiers, whether it is maximum or least material condition, is that this is not, I'm going to, hopefully you can see that, this is not the condition at which the part is built. So when this hole is produced, the desire is that it is nominally produced at 1 inch. And so in manufacturing, this is where the part is going to be produced. And there's going to be variation, and ultimately for the part to be okay, it has to vary less than the tolerance. But the part is not going to be produced at either side. So when we define a hole at maximum material condition that has nothing to do with where the part gets manufactured. I hope this helps a little bit with material condition modifiers, max material, least material. Hope you're having a great day. We'll catch you next time. See you soon.